My name is Don Ficken, for those of you who just joined us, and I'm with the Library Telescope program. I'm pleased to bring you our 45th Library Telescope program. We've been doing this for quite a while, and we have some folks on Zoom here, and hopefully some folks that will join us on Facebook. Tonight we have a really fun program about observing tips for the Library Telescope. You can imagine once you learn how to use the Library Telescope, it turns out it's actually pretty easy to use. You want to know how to find some stuff and what you can actually see. So we've got a guy tonight from St. Louis Astronomical Society named Mark Jones. He's been one of my mentors for many years, and he's going to give us some tips about how to find things in the sky. But first, before we get into that, let me just tell you briefly a little bit about the Library Telescope program. It was started in New Hampshire in late 2008, and we now have more than 1,000 library outlets throughout the world, something like 8 countries, particularly in the USA and Canada, and we're starting to get a pretty good foothold in Europe. And so these are really a lot of fun places to go to your local library. You can just check out a telescope just like a book. What a great idea, huh? And many of these many of these locations also have binoculars, and so it makes for really a round out, really nice evening here. So we have a number of resources you might find useful. Of course, one of our gurus is Tom Lynch, who's not with us tonight. He's got a Facebook page he's been managing for quite a long time. We really have a lot of stuff just about telescopes in general. He's always got some great little comics or it's just things, events that's going on. We've got nearly 7,000 followers. And we also have a website, librarytelescope.org, that has a world map of what we know are the participating libraries. There are probably a lot more, actually. So if you have a library, just go to our website and have them registered, and we'll get them on our world map. And so you can go to our world map, and let's say you're in the US, you can click on a state, and we'll show you the known outlets that are offering the program. And we have a lot of resources for patrons. For example, just today, I updated the front page with some nice maps put together of the star sky maps of the sky for the month of November. So we have October and November out there, usually in Spanish and English and some other things. So this is an example right here of that October sky map that I just talked about, and that's posted, I believe, also on our Facebook page, as well as having that on our front page. So you can see sometimes maps are so complicated you can't really find things, but this has got a really nice, simple series of things you can see, big events you can stuff. These are all items you can see with a library telescope. Really, really fun kind of things to take a look at. And if you don't know this, the night sky map does change each month. So you want to make sure you got roughly the right month to be able to figure things out. We've been doing these programs for some time. Tonight, we have observing tips for the library telescope. For the library telescope, last month we talked about hosting library telescope program star parties. And the month before that, we had a program on International Observe the Moon Night. Now, you can find all these videos right on the very front page of librarytelescope.org. Just scroll down. You can see we've had them for a number of years. Now, we're not going to be doing this in November, December. We'd like to take those periods off. Thanksgiving, the holidays coming up. But we'll hopefully resume this back at the end of or the beginning of next year. All right. So with that, I'm going to turn this over to Mark. I'll stop sharing just a moment. Again, post your questions on Facebook if you have some. And then on Zoom, we'll try to answer those at the end, and we'll get going here. So, Mark, I'm going to turn it over to you. Mark Jones.
All right. Thank you, Don. Can you hear me okay?
Yeah, hear you fine. Thanks.
All right. I'm going to share my screen here. And hopefully my screen is coming through for everyone.
Yeah.
Okay, great. Well, thanks for having me on tonight, Don. I've been really lucky to be involved with the Library Telescope program now for 10 years, and I've had a chance to, meet and talk to numerous library patrons and show them how to use the telescope and kind of be the gateway to their discovery in astronomy. So I hope tonight to maybe just share a few practical tips that I've learned and with the audience here tonight, and maybe that'll make your observing experience even more enjoyable. So let's go ahead and begin. I want to start with, see if I can advance my slide here. There we go. Let's just start with some refamiliarization with the telescope itself. This is a library telescope, And you probably went through this if you went through some training at your local library. But it's very simple to set up. You just have to set the telescope up on a tabletop somewhere, remove the dust caps, turn on the red dot finder if you have a red dot finder. Item number 2 here on the screen. Um, key thing to do is on the zoom eyepiece, set that to your lowest magnification, which is the 24 millimeter sign. We'll go over that in a few minutes. That designation is where you want to have the arrow pointed on the zoom eyepiece. Always start off there. You can loosen the tube clamp over here to rotate the tube for the best angle. I do that a lot, particularly with younger viewers, like kids and so on. If I got sitting on a tabletop, sometimes they can't stand up tall enough to look through the eyepiece, so I try to rotate the telescope down just by loosening the screw here, number 4 on this illustration, and rotating the tube downwards. Of course, for me or adults, you will probably want to have it rotated upwards so it's easier to look through. Always grab the telescope tube at each end. Move the telescope. This is one of the biggest things that I try to impress upon patrons, is to not use the eyepiece itself as a handle, but grab the tube at each end, left and right hands, in order to move the telescope up and down, left, right. You're going to look through the finder telescope that sits at the top here. You're gonna move that finder, and that will be what you first point at the object. Once you can find the object in this finder and get the finder pointed in the right direction, then the object should be visible in the main telescope, and we'll go through that a little bit more. Then obviously you look through the telescope eyepiece. You have to focus. There's focusing knobs on the side here, or focusing it for your eyes for maximum sharpness. And then you can rotate the zoom eyepiece to give you the higher magnification that makes the image larger, which is really important for viewing things like planets and some of the smaller craters in the moon. So here's some examples of how to hold the telescope and point the telescope. On the left, you'll see a person using their eye to look up through the red dot finder, and they're holding it from the back end and looking up through the finder to point the telescope. That's real good. Real good technique. Here's another technique where a person has it. They're holding with their the right hand at the back of the telescope, and their left hand at the front of the telescope. And in this case, they're looking through the eyepiece of the telescope to find their target or their object. Now, I mentioned focusing. Focusing knob is right here. And so you're going to look through the main eyepiece, and you're going to adjust this focusing knob here until you get your maximum sharpness or clarity of your image. Everybody's eyes are a little bit different. I like to take my eyeglasses off, and because my eye prescription is so strong, I need to refocus the telescope compared to somebody who has, say, 20/20 vision. But just remember, focusing knobs run either side of what's called the eyepiece mount or the focuser, and you adjust those. Finally, as I mentioned, zooming the telescope or changing the magnification. There's the 3-to-1 zoom lens that's on the telescope, which makes the object appear 3 times larger in size. You rotate the rubber knurled part of the eyepiece in order to rotate these numbers so that they line up with the arrow on the fixed part of the eyepiece. Right now you see it's pointed at 24 millimeters. That'll be your lowest magnification setting, about 19 power. And it'll rotate all the way over to 8 millimeters. That'll be your highest magnification, just a little bit under 60 power magnification. So those are really the key elements of the telescope. And of course, when you're done, you just basically reverse the process. Go ahead and focus the knobs, adjust the focus knobs until the eyepiece is retracted fully as far down as possible into the focuser. Then go ahead and turn off the red dot finder because it does operate on batteries. So you'll have to turn that off to preserve those. It's recommended you go ahead and rotate that zoom lens back to 24 millimeters, the lowest magnification, just so that next time you start off, you're starting off at that low magnification. Then go ahead and replace the dust caps on the eyepiece and on the front of the tube, and you're ready to take it back inside or return it to your library. Let's get a closer look at this red dot finder that I mentioned. There's a couple of adjustments on here. Now, normally when you get it from the library, the red dot finder should be aligned with the main telescope. But there are occasions where you'll have to make adjustments, and there are adjustment knobs for adjusting the red dot finder azimuth, or that's left and right, and altitude, or up and down, using this knob back here. And this is your power and brightness knob. This will turn on and off the red dot, and it'll also make the red dot brighter or dimmer, depending upon what kind of conditions you're in. You know, when you look up through the red dot finder, and this is one of the hardest things that I learned when I started using this telescope, is that you have to have your eyeball just in the right spot in order to see this red dot. So always make sure you can find that red dot. That's a skill that once you've learned that, uh, then you can proceed with actually pointing the telescope in the right direction. Sometimes I'll even take my hand and I'll cover the front of the red dot tube right here so that I'm not looking at anything, any bright lights behind it. And then I find the red dot inside of the tube. And once I do that, I remove my hand, and now I can see what's beyond the tube, and I can see what I'm looking for. Plus, hopefully, I maintain the position of the red dot. So here's an example. Here on the left, we see I'm trying to point the telescope and the red dot finder at the moon. Here's the moon in the distance. Here's my red dot. So I have to move the entire telescope. I have to grab the telescope by the back end, as this gentleman's doing, or grab it front and back, as we showed in the previous photograph. But grab it, grab the tube, and move the tube at the telescope until the red dot lines up with your object you're trying to see. That is really the number one thing you need to be able to do in order to find objects in the telescope. Once you have the red dot superimposed onto your object, in this case the moon, you expect to be able to look through the eyepiece now and see the moon, in this case, through the eyepiece. Now, when we're building up these telescopes, a lot of times we're working inside of a building. So we will use something on a far wall to align the red dot finder. In this case, we're looking at a clock face on the wall. And here's one of our members here. He's going through an alignment process. We point the red dot finder towards the clock on the wall. We then look through the eyepiece and see if the clock is there. If the clock is not there, we find the clock in the main telescope, and then we adjust those adjustment knobs that I mentioned that are on the red dot finder. Then we adjust those in order to bring the red dot finder in alignment with the main telescope. Now, hopefully, as a patron and a user, you won't have to do that, but that may be a step you'll have to go through in order to be able to align and point the telescope accurately. If you run into a problem, then take it back to your librarian and make sure that they're aware that the red dot finder is not aligned with the main telescope. Here's another example. So this is kind of a live example. We're looking at the planet Jupiter. And in this case, we're looking at the red dot, and we're moving the entire telescope until that red dot is right on top of the planet Jupiter. Now we should be able to look through our eyepiece and actually see Jupiter and its moons through the eyepiece. Were you able to see that video, Don? Did that show up to everyone? I'll run it one more time. Here we are, we're pointing the telescope. We have to move the telescope up, up, and to the
Yeah,
left a little bit?
it's showing fine, Mark.
Okay, good. And we move the telescope up and to the left until it's right on top of the planet Jupiter. And now you should be able to look through your telescope and actually see the planet in the telescope. Now, a little bit more about this eyepiece. We talked about it a little bit. It's a zoom eyepiece. It goes from 8 millimeters to 24 millimeters. So I think of it as a 3-to-1 zoom. From a from the specifications, from a technical perspective, this means that the focal length of the eyepiece is adjustable from 8 millimeters to 24. There's also some other statistics on eye relief, which for advanced users, that means how much distance you can put your eye from the lens in order to get a good view. I just recommend always put your eye up against a rubber eye cup for your best view. And then here's another important piece of information, particularly for advanced users. You'll notice that the field of view is not the same over the entire focal length range. It actually has a wider field of view, apparent field of view, at the shorter uh, shorter focal lengths, the 8 millimeter. And the apparent field of view actually shrinks slightly when we go to 24 millimeters. And I'll mention that again here on another slide. Now, as I talked about earlier, and I showed you in the illustration, you rotate this Knurl's rubber barrel here on the zoom eyepiece, rotate it to the different settings along here to get your different magnifications. So when we're at 24 millimeters, it's giving you an equivalent to about 19x or 19 power. So the moon or any other object is going to appear about 19 times bigger than with your eye by itself. And you can see that if you rotate it to the 18 millimeter mark, if you take this 18 and rotate the barrel to its on this arrow right here, you've now increased your magnification up to 25x. Rotate it further to 12 millimeters, you're up to 38x. And finally, when you go to the maximum and bring the 8 millimeters in line with the arrow, you're up to 59 power. And that's really a good power to use, particularly if you're looking at things like the rings of Saturn and the cloud belts on Jupiter and things like that. So I just want to go into that a little bit more detail. And of course, the focusing knobs on either side, whenever you rotate this zoom eyepiece to different magnifications, you may have to touch the focus knobs a little bit to resharpen the image. So make sure you do that to get the maximum image. Stars should look like pinpoints of light. So if you're focusing on stars, try to make those nice and small. If you see a star looking very large and circular, with maybe even a dark hole or shadow in the middle of it, that means you're way out of focus and you need to rotate those focusing knobs to shrink down the size of that star to a pinpoint. Now, how much of the sky are we really able to see with these telescopes? This is really important because it's really easy, or it's much easier to find things with just your naked eye. But when we start looking through telescopes, it's almost like looking through a soda straw. You're looking at a very small part of the sky. So to give you an idea what the size of the sky we're looking at, here's an image of the moon photographed through the library telescope with the power set to 24 millimeters, which is 19x. And we see that the field of view, that's the size of sky we're looking at, is about 4 times the diameter of the moon. The moon is about a half degree in size. So 4 times that's about 2-degree field of view. So that's about 2 degrees. And if you've been to some of our training sessions, a lot of times we'll say that if you hold your fist at arm's length, your fist is about 10 degrees in size. So if we only are able to see 2 degrees at our lowest magnification, that's about the width of your pinky or so. So we're looking at a small slice of the sky, and you have to point the telescope accurately in order to find the object you're looking for. Now, if we go to the other extreme, when we go to 8 millimeters in size, we're up to the 59x. And you can see the moon is much larger in size, but you can also see that the part of the sky that we're actually looking at is much smaller. It's not it's not quite a factor of 3 times smaller as you'd expect from the magnification. It's about a factor of 2 times smaller. And that's due to that apparent field of view change that we saw with the eyepiece. But just keep that in mind. That's why you always want to start when you're searching for an object, to always start at 24 millimeters on that indicator, have the arrow pointed to 24 millimeters to get your lowest power and your biggest part of the sky you can possibly see. And then once you find your object, then you can go ahead and adjust the focal length by rotating the zoom lens until you zoom up and make the image as large as you want it to be. Here's another way to look at it. Here's a typical star map that we have, and this is looking at the entire sky. So we're looking at a 180-degree horizon to horizon part of the sky, showing all the constellations and everything else that you can see. On that scale, 2 degrees is only a circle about that big. So if you take that circle and move it over here, you can see that you're only looking at a very small portion of the sky at any one time. This is why finding objects using the red dot finder, point at the objects first, is so very, very important. And you'll see that if you're down here at the 8 millimeter setting at 59x, the amount of sky you're looking at is 1.25 degrees in diameter. So it's a very small part of the overall sky. Sometimes people ask, can I look at constellations through the telescope? Well, not really, because you can see that we're only seeing this much of the sky, whereas constellations are much, much bigger. Even the very smallest constellations are much too big to see completely in a library telescope. But we use the library telescope, though, to look at individual stars, look at galaxies and nebula and planets and things like that. So let's start with the moon. Let's take the moon as our example. There's an example of a nice gibbous moon. And this is what it would look like at about 19x. And this is what it would look at about 59x. Kind of went through that a minute ago. Now here's a live video here in the center where I've got an iPhone attached to the eyepiece, and I'm zooming the eyepiece up to get the maximum size diameter of the moon. So you can see that when we're at low power, we're looking at this, where the moon looks small, and over here we're 3 times bigger. 1, 2, 3, 3 times bigger when looking at it on the 8 millimeter setting. So let's take a look at a few examples for this time of year. And I've actually got this set up this is just let's call it a star chart or a sky map. Here's a QR code for skymaps.com if you want to download these types of maps. Or you can use the maps that are on the Library Telescope.org webpage and download those as well. Well, let's take a look at one of these star maps. This case for the month of December coming up here, and let's take a look at some objects that are pretty common for us to look at. First, we're going to look at a double star. It's called Mizar Alcor, and this is a very popular object for us to look at, particularly in the spring and summer months of the year, even into the fall. As we get into winter, it gets harder to see the Big Dipper because it's sitting really low on the northern horizon. And I'm just going to use it in this example. The double star Mizar and Alcor are in the handle of the Big Dipper. In fact, they're the middle star in the handle of the Big Dipper right here. So what we're going to do, and remember, here's our field of view sizes that we talked about. So let's go ahead and go to the next page. Here's a simulation of what the size of Mizar and Alcor would look like through the telescope. Mizar is the brighter of the 2 stars, and Alcor is the fainter of the 2 stars that are visible. And if I magnify or zoom in to the highest magnification, I can make those objects appear further apart, as you see here, Mizar on the bottom, Alcor on the top. And if you look real close, you'll actually see that Mizar is a double, very close double star of its own. So there's actually several stars going on here. So let's take a look at the video on the next page. Here we are at low magnification of Mizar at the bottom, Alcor at the top. And you can just glimpse this one little star here. But now I'm going to zoom in. I'm using an iPhone 10, so it's not the best iPhone in the world by any means. Now I'm at the maximum magnification, 3 times bigger. And now we can see that Mizar is actually made up of 2 separate stars here. And we really like to show this at star parties. That's one of our most popular double stars that we look at. But there's hundreds of double stars that are visible that can be viewed with the library telescope. Let's go to our next object. Let's go to the planet Jupiter. And this time of year, particularly as we get into December, Jupiter will be rising in the east, and it's in the constellation of Taurus the Bull. It's actually, this is the face of the bull, and these are its horns. Jupiter's sitting almost right in between the 2 tips of the horns of the bull. And so let's go look at Jupiter next. So here's a picture of Jupiter at the low power setting, and here it is at the high power setting. And here you saw how we just zoomed in on it. Now I've kind of overexposed Jupiter. We don't see any detail on Jupiter, but I wanted to be able to see the 4 moons visible. So you can actually see all 4 of the moons visible, the Galilean moons that orbit around Jupiter. And every night that you look at these moons, they'll be in different spots because they are really orbiting around Jupiter like a miniature solar system. It's really quite amazing to look at. If I were to shrink my exposure down with my iPhone a little bit more, I could now start to see the cloud belts. These are brown or dark stripes that appear on the surface or in the atmosphere of Jupiter. You don't see them in this view, unfortunately, but look for them next time you use the telescope. They run parallel with the same line that the moons are in. Jupiter's moons appear to move back and forth in a line. They don't go around like this because from our Earth's vantage point, our Earth, we're looking at Jupiter in the same orbital plane as the moon's orbit. So they appear just to move back and forth in a line. And the cloud belts on Jupiter parallel the equator of Jupiter. So those cloud belts also run parallel with the direction of the moon. So next time you have the telescope out, see if you can detect those brown stripes or dark stripes or bands. There's usually at least 2 of them visible in Jupiter's atmosphere. Let's go to the next object. This time of year, there's lots of good objects to look at. The Pleiades, which are also called the Seven Sisters or Subaru in the Japanese culture, is one of our closest open star clusters in our galaxy. It's only about 400 light years away. You can see it with your naked eye. It looks like a small little dipper. Some people say, "Is that the little dipper up there?" No, it's actually the Pleiades, a star cluster. So let's take a look at what that looks like through the telescope. So here's a simulation of that. What it's going to look like. It's going to look like a little dipper. You can kind of see it there. And this would be the simulation of what it would look like at 19x. And if we zoom way in, you'll see that we're only going to see part of the cluster when we go all the way up to 59x here. We're only going to see a few of the stars. And then you'll have to move the telescope around in order to point it at different parts of the star cluster. So let's take a look at that video. Here we go. You can see the dipper or the Seven Sisters, and I'm going to zoom in here. And as I get into higher and higher magnification, you can see that sure enough, I cannot see the entire star cluster anymore. I'm now seeing just some of the stars. And then I need to just move the telescope very slightly in order to see them, but I cannot pick them all up all at the same time. let's go with one final object, and this is and it's a nebula. It's the Orion Nebula, located in the constellation of Orion. And in the month of December, it's rising in the east after it gets dark and gets on the meridian. By late December, it's on the meridian around the meridian meaning due south, about due south about midnight or so at the end of December. You might be familiar with the three stars in Orion's belt. You've probably heard of the bright red supergiant star called Betelgeuse that sits up here in the shoulder or the armpit of Orion. Orion's holding a club. This is an arm. He's holding a club here, and he's holding a shield with his other arm. Down here on his left knee is the bright star Rigel. But we start with these three belt stars in Orion, and below those, towards Rigel, there's a little fuzzy area that it's called Orion's sword because it's a little small line of faint fuzzy stars. And right in the middle of that faint fuzzy line of stars is actually where the nebula is located. And here's a picture. I didn't do a zoom in, but this is an actual picture taken with my cell phone. Once again, it's just an iPhone 10, so it's not a super sensitive picture. But you can see this glow around some of the stars. That is the nebulosity of the Orion Nebula. It's you can actually see it, I think, better with your eye than you can with an iPhone 10. Uh, this is a stellar nursery. This is where new stars are being born. I won't say every day, but since stars are born over a period of hundreds of thousands of years, most of these stars here are newly formed stars that might be 10 million years old or less. They're hot blue stars that emit a lot of it's called ultraviolet radiation. And we know that ultraviolet radiation can give you uh, sunburns, but because it's very highly energetic light. But ultraviolet radiation can also cause the gas that's surrounding these stars to fluoresce, to emit and glow with light. And that's what we're seeing here. We're seeing the glowing effect of those clouds of gas that are being excited by the ultraviolet light of these very hot young stars. And that's what you're looking at when you look at the Orion sword in the Orion Nebula. So I hope you've hope those will give you some ideas on what to look for this. Let's go back to our December page here. Those are just a few objects visible coming up in the months of November and December. It's really a great time of year to get out. It gets dark early, so you can go out right after dinner time, before bedtime, and look through your telescope. And I hope this has given you a few tips on uh, how to use the library telescope. So with that, I think I'll stop my presentation and take any questions or comments that people have.
Well, that's great, Mark. This is helpful because it is confusing, I think, when you get outside and you're trying to figure out, what you're seeing if you don't really even know the field of view. Um, it's like looking through a straw, I guess, if you magnify too much, and really a very tiny straw, right? So, um, uh, one question, Mark, we have you mentioned Jupiter, and I think Jupiter is going to start coming up pretty soon, early in the evening, right? I think starting late, is it late in November and into December, it should be up near sunset time kind of thing. Is that right? Because right now it comes up a little later, right?
Yeah, it comes up. I saw it a few nights ago, probably about 10 o'clock. Um, so quite a bit after sunset. But it reaches what's called opposition. I think it's in November. Maybe somebody can check that for me.
Okay.
But that means that opposition means that it's the object is between us or on the opposite side. Say, the Earth is between us. Sorry, the Earth is between the object at opposition and the sun. So if the sun is setting in the west, the object that's at opposition is in the east, rising in the east. And so Jupiter's opposition is coming up here soon. I would have to Google that right now. Sorry, to tell
That's
you
okay. Yeah.
the
So,
exact date of opposition.
yeah. So another question then. So how do binoculars fit into what you're doing here? Because I think if I'm correct, binoculars have even a wider field of vision. So sometimes you use binoculars to help you figure out where something is so you could put a telescope on it, or how does that work?
Well, you could if you have access to binoculars. For example, my binoculars are what's called a 10 by 50 binoculars, and they have about a 7.5 degree field of view.
So
So if we look,
what does the 10 mean now? What does the 10 mean?
the 10 means 10x,
All
10
right.
magnification. It magnifies things 10 times your normal eye.
Okay. And that's compared to the
Okay.
19 of the starting of the telescope, library telescope. So it's about half the magnification. Is that right, roughly?
Yes,
Yeah, okay,
about
good.
half the magnification. But they typically have a wider field of view than telescopes do, and my particular one has about a 7.5 degree field of view at that 10x. So you would take, for example, this little 2 degree circle, and you'd have to, make that about 3.5 times larger in
Got it.
size
Okay.
to replicate what you see in binoculars, which is great because now with my binoculars, I can almost see all three of the belt stars in the field of view of my binoculars at the same time. That's kind of nice.
Right, right.
Um, and other objects too. The Pleiades, I can definitely see, all of the Pleiades easily at one time. Or there's another cluster right down here called the Hyades in the face of the bowl, which is an even larger cluster of stars. They're V-shaped. That would also be, you could see that with a pair of lower power binoculars.
So you mentioned Mizar and you talked about different parts of the year that you can see it differently. So is the is the Big Dipper always visible to us in the North America?
In our latitude, we can see the Big Dipper pretty much year round. In the December months, November, December months of the year, the Big Dipper that you see here is hugging the north horizon. It's below the pole star. The North Star called Polaris is here, and the Big Dipper will be below the pole star. If I go back to, I think I had another star chart. Let's see. Let me go back a little further. Here we go. Here's a star chart from the springtime of the year, and here you might notice that here's the North Star again. And in December, we saw that the Big Dipper was down near the north horizon. Now we see this is the springtime view, really about April. We see the Big Dipper is above the pole star. The Big Dipper is almost straight overhead, almost at the center of the circle. The circle represents our entire horizon, and the center of the circle represents zenith or straight overhead. So we can see that the Big Dipper in the springtime is almost straight overhead. It's way up high, and that's when it's best observed is in the springtime of the year. In the fall, we'll see the Big Dipper more towards the northwestern horizon. And then as we get into late fall and early winter, it's down here uh, near the north horizon. And then as we get into late winter, early spring, it's over here on the east. And then as we get into late spring, it's almost straight overhead. So it's, as you mentioned earlier, you need a star chart for every month because patterns don't change, but which star patterns you see does change from month to month because of our orbit around the sun we're always looking, the night sky is always pointed away from the sun. So we're always looking at a different, think of it as a merry-go-round, and you're on a merry-go-round, and the hub of the merry-go-round is the sun. And as you go around waving at your friends that are watching you on the merry-go-round, sometimes you see your friends, and you wave at them, but then you have to wait until you go back around for the merry-go-round to spin around again one more time, where you see your friends again.
Okay.
And so the same thing happens when we're looking at the sky.
All right. So we have one more question. And by the way, I think we have a hello from India. So that's good. Thank you, Pearl, for joining us tonight. So the last question, not a big surprise. What about the comet right now that's going on? Everybody wants to know where the comet is. Can you see the comet in the library telescope?
I have not tried it. I don't have a library telescope with me where I'm at right now, so I haven't been able to try one out. But I'm very, very confident that you would see the comet in the library telescope. I have seen it with my unaided eye. I have seen it in binoculars. And so if I can see it with my unaided eye and binoculars, I'm very confident that I could find it with the library telescope. Now, what would I see different through of the comet compared to my naked eye or through binoculars? Well, so first of all, it'd be larger in size because my binoculars are 10x, but the library telescope is almost 20x. So the comet's going to look, twice as big as it does through my binoculars. If there's any detail in the comet, if the tail of the comet or the head of the comet has any sort of structure to it, I'm more likely to see it while looking with the library telescope than I would see it with my eye or with a pair of binoculars. And we know that the aperture on the library telescope collects about 250 times more light than your eye by itself. It's a big light funnel that collects a lot of light. So things look 250 times, as theoretically anyway, 250 times brighter than with your eye alone. So I would expect to be able to see the comet, brighter in the sky than I could with just my eye by itself.
So they would look, I think they look the west right now, right around just after sunset. Is that correct? Almost directly west?
That's right. Yes. Right now, the comet is in the evening sky. It sets around maybe 9 p.m., which means it goes below the western horizon about 9 p.m. What I've been doing is going out right after sunset, gonna wait till it gets dark and I start to see the first stars. I look out to the west. To the southwest, I'll see Venus. The brightest star in the sky is the planet Venus to the southwest. To the northwest, I'll see a very bright star, and that is Arcturus. And kind of in between those two, halfway in between Arcturus and Venus, is where the comet is. But it'll be much higher in the sky than either Venus or Arcturus.
All right. Well, I think that's going to wrap it up for us, Mark. Wow, that was great. And again, we'll be posting this video for those of you that are on Facebook that would like to replay it. Of course, you can just play it back on Facebook, but you can also go to our librarytelescope.org and you can play it from there. So this is some good stuff. I think if you watch this, you might want to go back and watch it again because these tips about the number of degrees you see will really help you when you're trying to find an object. And so, anyway, it's a great I think a great foundation for those of us who are getting used to it. And I've been doing this for a while, and Mark always teaches me something brand new every time I go through this. So this is really great. So we're going to wrap it up. And again, we're not going to have some webinars in November, December, simply because of the end of the year stuff. We get all busy, and we'll try to resume back in January. And thanks for joining us. We appreciate this. And Mark, thank you for a great job tonight. Once again, we'll get this posted on our website probably sometime tomorrow afternoon. All right. So have a great evening and thank you.
Thank you.